And next one, properties of convolution. Properties of convolution. So these are the topics for midone examination. So properties of convolution is a theory questions. I'll try to cover. If not, I'll give the material. So I'll solve the problem for convolving to continuous time signal and convolving to discrete time signal, and how to check stability of an LTI system in both cases, continuous time LTI system as well as discrete time LTI system. Right? Okay. First topic, representation of discrete time signal in terms of impulses. So any discrete time signal can be represented with the help of shifted version of the impulse signal. X of n equal to x of n into del of n minus k, where k varies from minus infinity. Okay. So if you want to verify, if you want to expand this, substitute n equal to k equals sorry. So I'm just changing the notation. X of k del of n minus k, where k varies from minus infinite to infinite. Substitute k equal to 0, x of 0 del of n, k equal to 1, x of 1 del of n minus 1, plus x of 2 del of n minus 2, and so on. In negative direction, x of minus 1 del of n plus 1, plus x of minus 2 into del of n plus 2, and so on. So this is the expansion of this particular equation. So if you want to verify, we'll take one simple discrete time signal. Let's say this is our discrete time signal x of n, 0, 1, 2, minus 1, minus 2. Okay. Simple example and okay. This signal x of n can be written as x of n equal to summation, in general formula minus infinite to infinite, but here minus 2 to 2. Okay. So in general x of k del of n minus k. So if you multiply this signal with del of n meaning at n equal to 0 magnitude 1. Okay. X of n del of n. If you multiply x of n del of n at n equal to 0, whatever value available, that only we will get, plus next. So to multiply this signal, same x of n signal, with del of n minus 1. What is del of n minus 1? At n equal to 1 magnitude 1. Okay. And multiply this x of n signal with del of n minus 2. N minus 2 meaning 0, 1, 2. Okay. So what is the result of this? X of n multiplied with del of n at n equal to 0 magnitude 1. At n equal to 0 magnitude 1. So remaining all other values 0. That meaning whatever information available at x of 0 position, that you will get. Okay. X of n, if you multiply it with del of n, your result will be equal to x of 0. So if you multiply x of n del of n minus 1 at n equal to 1, here values available. Remaining all other values of n 0. So whatever value available at n equal to 1, that is your result. So x of n, if you multiply del of n minus 1, that will be equal to x of 1. Okay. So x of n minus 2, if you multiply with x of n, so del of n minus 2 multiplied with x of n, your result would be x of 2 1, and so on. So we can write x of n in terms of shifted version of the impulse signal. In general, x of k del of n minus k. X of n equal to x of k del of n minus k. Just remember this formula. Right. X of 0 del of n. This step. X of 1 del of n minus 1. Del of n minus 1 is x of. Okay. If you add all these signal, you will get x of n. So the point to be noted here, any continuous time signal can be represented shifted version of its impulse signal. Okay. Just few example I have given here. Similarly, if we go for negative side also, say for example, del of n plus 1. What is del of n plus 1 sketch? At n equal to minus 1, you will get sample. At n equal to minus 1, the magnitude of the signal is 1. So x of n multiplied with del of n minus 1. X of n, if you multiplied with del of n minus 1, your result would be whatever at n minus 1 information available, you will get the same information. Okay. So x of n is equal to x of 0 del of n plus x of 1 del of n minus 1 plus x of 2 del of n minus 2 and so on. Negative side, x of minus 1 del of n plus 1 plus x of minus 2 del of n plus 2 and so on. Okay. So this equation you have to remember first. Similarly, for continuous time signal, any signal x of t can be represented its shifted version of its impulse signal. X of tau del of t minus tau into d tau. Okay. Either discrete time signal or continuous time signal, we can represent both the signal in terms of shifted version of the impulse. Okay. These two formula you have to remember. Now let us derive the output of an LTI system or impulse response or response of a discrete time LTI system. First, let us derive response of discrete time LTI system. What is LTI system? The system must satisfy linearity principle and time invariant principle. Time invariant principle. These two must be satisfied. Then the system is LTI system, linear time invariant system. Okay. Now, we'll consider an LTI system. Suppose if the input to this LTI system is del n, that is unit impulse, then the output of the system called as y of n equal to transfer function of del of n, that is called as h of n. Then the system output represented by h of n. So this is called as impulse response. Impulse response. When the input to the LTE system is impulse signal, then the output of the system called as impulse response of the system. Clear? So init impulse is used as the test input to a system. Okay. At n equal to 0, the magnitude of the signal is 1. If you apply this Please remember this. Okay? Right. Now, consider an LTI system. So we are applying the input signal x of n and the system output represented by y of n. So y of n equal to transfer function of x of n. Y of n equal to transfer function of x of n. System will do some modification on this x of n. Our system will process that input signal. Depending on the behavior of the system, it gives some response. That is y of n. Right? Okay. Now, in the previous slide, we discussed any discrete time signal. Any discrete time signal can be represented shifted version of the impulse signal. That is summation x of k h of x of k del of n minus k. Okay. X of k del of n minus k, where k varies from minus infinite to infinite. Let us assume a LTE system. The input to the system is x of n. Output of the system y of n equal to transfer function of x of n. Okay, any kind of LTE system. So x of n, a discrete signal, can be represented with the help of shifted version of the impulse signal using this concept. X of k del of n minus k, where k varies from minus infinity. Right. So from this equation now, apply the linearity principle. What the linearity principle says: if x1 is input, system output is y1. If you multiply a constant with the x1, some input, your system output should be equal to ay1. Okay. So this is one property in the linear, that is scaling property or homogeneous property. So in this equation, x of k look like a constant. Your del function only shifting each and every time. So I'm rewriting this equation: k equal to minus infinite to infinite, x of k transfer function of del of n minus k. As per linearity. As per linearity principle. So in this example, or linearity property, in this example, x of k look like a constant, del of n minus k. This signal only shifted each and every time. So transfer function of, well, I'll write here, transfer function of ax1, that will be equal to a into transfer function of x1. So now you can understand clearly. Let's forget about this. Transfer function of ax1, that will be equal to a into transfer function of x. So it look like a constant. So I'm taking this outside. So transfer function of del of n minus k. Okay. Now, as per time invariant property, as per time invariant property. So what do you mean by time invariant property? I'm giving input x of t, system gives output y of t. If my input is delayed by some amount of time, my output also should be delayed by same amount of time. So that is time invariant property. Okay. So del of n minus k, meaning del of n input is delayed by k amount of time. So in the beginning of this particular topic, what we studied, if del of n is input, if del of n is input to the LTI system, the output of the system called as h of n, impulse response of the system. So if the input del of n is delayed by k amount of time, as per time invariant property, the output also should be delayed by same amount of time, h of n minus k. Okay. That is h of n equal to transfer function of del n. H of n equal to transfer function of del n. If the input is delayed by k amount of time, then output also should be delayed by k amount of time. So apply the time invariant property in this particular step. Summation k equal to minus infinite to infinite x of k transfer function of del of n. Transfer function of del of n is h of n. Then transfer function of del of n minus k as per the time invariant property h of n minus k. So this term replaced by h of n minus k. Okay. So we have derived the output of a discrete time LTI system, that is y of n equal to x of k h of n minus k, where k varies from minus infinite to infinite. Otherwise, this can be represented by x of n convolution with h of n. X of n convolution with x. So this star symbol indicate convolution. What is the meaning of convolution? One signal is fixed, another signal is shifted from minus infinite to infinite. Then we have to multiply with x of k at each and every shift and accumulate together. Okay. So y of n equal to x of n convolution h of n. This is general formula. What is the actual meaning of this convolution? Y of n equal to x of k int h of n minus k, where summation k varies from minus infinite. So sometimes in your semester exam, you will get the theory questions. Derive the response of an LTI system, or derive the output of an LTI system, or derive the convolution sum. Okay. So in discrete time, this is called as, this expression called as convolution sum. Derive the convolution sum of a discrete time LTI system, or derive the response of a discrete time LTI system, or output of the discrete time LTI system. Both are same. Okay. So I'll summarize here once again. Assume del n is input. The output of the system called as impulse response h of n. Okay. H of n equal to transfer function of del n. Next. In general, assume some input we are applying to LTI system x of n. System response y of n. Y of n equal to transfer function of this x of n. So the beginning of today class we discussed any discrete time signal x of n can be written as summation k minus infinite to infinite x of k del n minus k. That is shifted version of the impulse signal. So example also we discussed. Okay. How a signal x of n can be represented shifted version of the impulse. Okay. Next, linearity principle. Transfer function of a x1, that will be equal to a is a constant, a into transfer function of x1. So in this equation, x of k signal is fixed. Only this impulse signal is shifted each and every time. So I consider this as a constant. So a constant, transfer function of del of n minus k. Transfer function of del of n is h of n. As per the linearity principle, if the input is delayed by k amount of time, then output also should be delayed by same amount of time. So transfer function of del of n minus k represented by h of n minus k. Okay. So finally, the formula for convolution sum, or response of discrete time LTI system, or output of discrete time LTI system, y of n equal to summation x of k h of n minus k, where k varies from minus infinite to infinite. The symbolic representation of this particular expression, y of n equal to x of n convolution with h of n. So this is an important theory questions for your semester examinations. So let us solve some problems using this formula, x of k, h of n minus k formula. Then you will get a clear idea. Okay. First example, find the convolution sum or determine the convolution. Remember the name, find the convolution sum or convolution between discrete signal or response of LTI system. Both are same. Okay. So from the previous derivation, what we understood, if we know the impulse response of a system, if we know the impulse response of an LTI system, what is impulse response? When the input to the system is del of n, then the output of the system called as impulse response. So if we know this particular information, we can able to estimate a LTI system output for any kind of input x of n. That is y of n equal to x of k h of n minus k. So that is the beauty of this LTI system. If we know the impulse response of the system, we can easily estimate the output of the system for a given input x of n. Here just I'm changing the notation k to avoid the confusion. Okay. So response of LTI system, meaning by default you have to use this formula. Not a normal system, response of LTI system, because with the help of linearity as well as time invariant, we have derived this formula. So response of LTI system for the given x of n and h of n, then obviously you have to go with this formula. Okay. First problem, find the convolution sum or find the response of LTI system if the input to the LTI system is 1, 4, 3, 2. And the impulse response of the LTI system is 1, 3, 2, 1. Okay. What do you mean by impulse response? When the input is del n, the LTI system gives some output. That is impulse response. So we know the impulse response. Now the arbitrary input x of n, that also given. Now we have to find out the response of LTI system or convolution between these two sequences. Both are same. So in this example, they have indicated arrow mark at 4. What do you mean by this arrow mark? In discrete time representation, if arrow mark is specified, what it does mean?
At time 0, sir.
Okay, this is 0th position, x of 0 position. Second one, nothing is specified. So by default, you have to assume the starting sample is at t equal to 0 position. Understand? Okay, so you have to read the question carefully in the question paper and do this y of n calculation accordingly. If arrow mark is not specified, the first sample magnitude at t equal to 0 or n equal to 0. Okay, so we shall write the formula x of k h of n minus k, where k varies from minus infinite to infinite. So how to perform this? First step, all x of n written by x of k, 1, 4, 3, 2. Okay. Next, h of n replaced by h of k. 1, 3, 2, 1. Now use this formula. X of k, h of n minus k formula. Understand? X of k is given your x of n. First step, you replace all n by k. In input of Lte system as well as impulse response of Lte system. Now according to this formula, x of k is fixed. So we have to sketch x of k. H of k, particularly h of n minus k. So this particular signal will be varying from minus infinite to infinite. At each and every time shift, we have to multiply it with x of k. So I'll show you one small video, you can understand. Actually, this is available for continuous time signal. But anyway, you can understand the discrete time signal concept. Okay. Suppose if you want to perform convolution between two signal. Convolution between two signal. This is a signal 1, this is a signal 2. So how to do this? One signal is fixed. Another signal is time reversed. X of k, h of minus k. Right? X of k. Then we need to plot h of minus k. Then this h of minus k signal shifted from minus infinite to infinite. That is the value of n. Okay. So if you look at this particular example, one signal is fixed. Another signal is time reversed. And that particular signal shifting from minus infinite to plus infinite. At each and every shift, we have to multiply these two signals and whatever the result that we need to write. So this is the exact operation of a convolution in discrete time signal as well as continuous time signal. Okay. One signal is fixed, another signal is time reversed, and the time reversed signal need to shift from minus infinite to plus infinite. And each and every shift, we have to multiply it with that first signal. Once if there is no overlapping between these two signals, that is x of k, h of minus k. So now at this particular point, there is no overlap. Now your output is 0. Okay. So this is actual the meaning of convolution between two signals. X of k, h of k. So according to this formula, do the sketch. X of k signal. In your notebook, you have to do the sketch on the same page so that you can multiply both signal magnitude easily. K versus x of k. 0, 1, 2, 3, 4. So in this example, this is 4. 4 meaning at 0 magnitude 4. Okay. Here it is 1. At 1 magnitude 3. At 2 magnitude 2. So x of k I have plotted. Formula. Now h of minus k. I have to plot h of minus k. Okay. First h of k you plot somewhere else, and then h of minus k you plot here. H of k 0, 1, 2, 3. 1, 3, 2, 1. This is h of k. As per the formula, we need h of minus k. Okay. Need h of minus k. K versus h of minus k. So 0 to 3. H of minus k, minus 1, minus 2, minus 3. At 0 magnitude 1, 1. At minus 1 magnitude 3. At 2 magnitude 2. At 3 magnitude 1. Then x of k, h of minus k. So now If we multiply these two signal, that will be equal to summation x of k h of minus, that is n equal to 0. So if you multiply these two signal, you will get y of 0. Do you understand? In this equation, substitute n equal to 0. Y of 0 equal to summation x of k. This is fixed. H of minus k. Okay. Y of 1 equal to summation x of k h of 1 minus k. So we need to plot h of minus k, h of 1 minus k, h of 2 minus k, and so on, and reverse direction. H of minus 1 minus k, h of minus 2 minus k, and so on. Then we have to multiply x of k with h of n minus k signal until there is a overlap between these two signals. Okay. First step in the equation, I have substituted y of 0. Y of 0 equal to summation x of k h of n minus k. Okay. In general formula, y of n equal to x of k h of n minus k. For n0, x of k h of 0 minus k. This is nothing but h of k. Now multiply these two signal. 4.1. 4. Okay. And 1.3. 3 plus 0, 0, 0 dot anything 0. Here it is 0, 0, 0 dot anything 0. So what is y of 0 value? 7. Next step. Now substitute n equal to 1. Summation x of k h of 1 minus k. Okay, h of 1 minus k. Or x of k h of minus k minus 1. Both are same. Sorry, minus k plus 1. 1 minus k or minus k plus 1. Both are same. So how to plot minus k plus 1 signal? K plus 1 first and then reverse. Okay, as per the procedure. Or if you take minus k initially, time reversed signal, and then plus 1 represent right shift by 1. Otherwise, my suggestion for the student, you always follow the unit 1 procedure to plot minus k plus 1, time shifting first and then time reverse. So you will get this signal like this. So this is h of 1 minus k. Okay. Now if you multiply these two signals, so what is the value you will get? Here x of k. Okay. You have to multiply x of k with h of 1 minus k. So minus 1, 1. So 1 into 2, 2. Okay. And 0, 4 into 3, 12. Next, 3. Here into 1. 3.1, 3. So really is 17. So at y of n, your value is 17. Next, further plot h of 2 minus k. That is, in this equation, if you substitute n equal to 2, y of 2 equal to summation x of k h of 2 minus k. 2 minus k is equal to minus k plus 2. Okay. We have to do repeat the same procedure until there is a no overlap. And The n negative value of n also we have to check. So 0, 1, 2. Now 1, 3, 2, 1. So this is h of minus k plus 2 signal. You can check. You plot k plus 2 first and then time reverse, you will get this signal. Now multiply x of k, h of 2 minus k. X of k, h of 2 minus k. So minus 1, 1 magnitude, minus 1, 1. So 1 dot 1, 1 plus 4, 4, 2, 8 plus 3, 3, 9 plus 2, 2 dot 1, 2. Okay. So 17 plus 2, 19 plus 1, 20. So y of 2 value 20. Y of 2 value 20. Okay. So can you check similarly? You go for 3 minus k, 4 minus k, and so on. Because 2 minus k, still how many sample overlapping? Minus 1, 0, 1, 2. So minus 1, 0, 1, 2. Next, all possible value we have to check. Substitute n equal to 3. Y of 3 equal to summation x of k, h of 3 minus k. Plot h of 3 minus k. So 3 minus k is similar minus k plus 3. So this procedure will be repeated. K versus h of 3 minus. Now 0, 1, 2, 3. So 1, 3, 2, 1. Multiply x of k signal with h of 3 minus k. So minus 1, here minus 1, no information. From 0 to 3. Here it is 0 to 2 only available. So now multiply magnitude at k equal to 0, 1, 2, 4, 4.1, 4.1, 4. Next, k equal to 1, 3. Here 3 times of 2, 6. Okay. K equal to 2, magnitude 2. 2 times of 3. 2 times of 3, 6. Plus at k equal to 3, 0 here. Nothing is there. So 0 dot anything 0. So y of 3 value 6 plus 6, 12 plus 4, 16. Okay. Next. So similarly, I advise you to calculate y of 4. Y of 4 value you will get 7. And y of 5 value you will get 2. Do the sketch for h of 4 minus k, h of 5 minus k you will get. Now, if we plot y of 6, that is x of k, h of 6 minus k. So h of 6 minus k okay, and just skip the 2 step. You do it for h of 4 minus k. Plot the signal h of 5 minus k. Plot the signal and h of 6 minus k. Okay. So 4 minus k complete. Okay. 4 minus k signal available from 1, 2, 3, 4. For 5 minus k signal available from 2, 3, 4, 5. Correct? So magnitude 1, magnitude 2, magnitude 3, 1. So magnitude 1, 2, 3, 1. So 5 minus k at k equal to 2, 1. And here k equal to 2, 2. So 2 times of 1 you will get 2. So if you plot h of 6 minus k, 0, 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 1. Now if you multiply your x of k, summation x of k, h of 6 minus k. Check. H of x of k, the signal available from -1 to 2 only. From minus infinite to minus to 0. From 3 to infinite 0. Okay. So h of 6 minus k, the signal available from 3 to 6. So if you multiply these two signals, there is no common signal. There is no signal overlapping between x of k, h of 6 minus k. Because from -1 to 2, here the information is 0. So 0 multiplied with any value x of k, 0. Okay. Then if you shift right side one bit, one step right side, then h of 7 minus k and so on, then you will get obviously 0. So you stop calculating up to this particular step. This is for only n positive value. In this formula, we substitute n 0, 1, 2, 3, 4, 5. Up to 5, there is a signal overlap between x of k, h of n minus k up to n value 5. Correct? When n value 6, then multiplication result is 0. There is no overlap. As in this example, when this signal started crossing this particular portion, there is no overlap. Okay. Up to this overlap. Once it is crossed, there is no overlap. There is no common region between these two. In continuous cases, similar cases in discrete also. Okay. You stop up to this step. Now we have to check negative value of n. We have to check negative value of n. Y of n equal to x of k, h of n minus k. General formula. Substitute y n value 1. Summation x of k, h of -1 minus k. Or this can be written as minus k minus 1. Okay. Now we have to plot h of minus k minus 1 signal and multiply with x of n and accumulate. Meaning the magnitude at each and every time instant multiplied plus added together. Okay. So up to the previous step, n positive value we completed, then we identified that n equal to 6, there is no common sample between these two signals. Okay. What is x of minus k? X of minus k, this one. -3, -2, -1, 0. Okay. Then minus k minus 1 represent. First, you can do k minus 1 and then time reversal. Or minus k minus 1 represent after finding h of minus k, left shift by 1. I'll write here. So h of minus k minus 1. For your understanding, I'm once again I'm drawing the signal x of k here. What is x of k? 0, 1, 2, 3, minus 1. Minus 1, 1. And this is 4. And this is 3, 2. Correct? Mine 1, 4, 3, 2. This is x of k. Now minus k plus 1. Sorry, minus k minus 1. So minus 3 to 0. Now your signal will okay. So usually how to plot h of minus k minus 1? In unit 1, I suggested for you h of k minus 1 first and then time reversal version. Okay. Or if you plot h of minus k first and minus 1 represent left shift by 1. Opposite it is. Okay. So you can follow any method, but draw h of minus k minus 1 signal clearly. So minus k minus 3 to 0. Now minus 1 meaning minus 4 to minus 1. Right. What are the sample? 1, 2, 3, 1. Okay. 1, 2, 3, 1. 1, 2, 3, 1. Now multiply these two. X of k. Sorry, x of k. X of k, h of minus k minus 1. So at k equal to minus 1, 1. 1.11. Remaining value 0 here. And for this here 0 magnitude. Okay. So if you substitute the n value minus 1, your result is 1. Y of minus 2, summation x of k, h of minus k minus 2. So what is h of minus k minus 2? Again, this signal shifted one step left. Okay. 1, 2, 3, 1. So multiply your x of k, h of minus k minus 2. From minus 4 to minus 2, sorry, from minus 5 to minus 2, there is no sample, 0. So 0 multiplied with this value, your y of minus 2, 0. If you go for minus k minus 3, again there is no overlap. Okay. So this is first method. If two signals are given in the question paper, one is x of n, another one is h of n. Or sometimes they will give x1, x2. No issue. You follow this procedure. x1 of k, x2 of n minus k. Okay. Here is x of n of LTI system. Input to the LTI system. Impulse response of the LTI system. So we have derived the response of discrete time LTI system. That is y of n equal to x of k, h of n minus k, where k varies from minus infinity to infinity. Okay. How to solve this equation? X of k first. H of minus k. One signal fixed, one signal time reversed. And the time reversed signal need to shift from minus infinite to infinite in general. But in this example, we found when you plot n equal to 6, h of 6 minus k. H of 6 minus k, there is no overlap. So you can stop up to this step. Okay, because 6 minus k, there is no common sample. Similarly, for negative value of n value minus 1, only one sample is overlapped. K equal to minus 1, k equal to minus 1. So 1 dot 1. N value minus 2, no samples are overlapping between x of k, h of minus k minus 2. Then you can stop up to this particular step. Okay. In general, summation minus infinite to infinite. But depending on the given x of n, h of n, or x1 of n, x2 of n, you have to stop your calculating your y of n value for positive value of n as well as negative value of n. Okay. Now write down your final result. For the given x of n, h of n, we have performed the convolution sum. So the resultant y of n is equal to, starting from minus 1, y of minus 1 equal to 1. Okay, this is y of minus 1 position. Y of 0 value, y of 0 value 7, 7, 17, right, 7, 17, 20, 7, 17, 20,
16.
and then 16, 7, 2, correct?
Yes, sir.
So here also you have to mention the arrow mark. This arrow mark indicate your y of 0 position. This arrow mark indicate your y of 0 position. So this is the method to find the convolution between two finite signal. It's your luck only. If finite signal comes for the discrete time signal, you can easily calculate the convolution sum. Actually, the problem is very simple. Just some steps are involved. Follow the procedure clearly and identify this. Okay. By default, convolution meaning you have to go with this procedure only. This procedure called as graphical procedure. We are plotting x of k, h of minus k, and we are shifting the h of minus k from minus infinite to plus infinite. Each and every shift we are multiplying with x of k and write down your result. So that is a simple procedure. Finally, you have to write down this result also. Okay. Suppose if these kind of problems comes in your examination, finite signal x of n finite, h of n finite. So one more techniques available. Using these techniques, you can cross verify your result, whether your obtained result are correct or not. So how to cross verify this result? By using matrix method. X of n equal to 1, 4, 3, 2. Arrow mark indicated at 4. H of n equal to 1, 3, 2, 1. No arrow mark indicated. By default, this is your h of 0. First, you write down like this: 1, 4, 3, 2. Next, 1, 3, 2, 1. Okay, 1, 3, 2, 1. Now multiply 1 dot 1, 1, 4, 1, 3, 2. 3, 1, 3, 3, 4, 12, 3, 3, 9, 3, 2, 6. 2, 1, 2, 2, 4, 8, 2, 3, 6, 2, 2, 4. 1, 1 dot 1, 4, 3, 2. Form a matrix and multiply one by one. Now, diagonally you have to add the value. This is only for verification purpose. You are not supposed to follow this method for the examination. You always use the graphical procedure only. First write down your y of n, then I'll tell you where to indicate the arrow mark. 1. 4 plus 3, 7. So 12 plus 3, 15 plus 2, 17. 9 plus 8, 17 plus 3, 20. 6 plus 4, 10 plus 4, 14. 16 now. Sorry. 16. Okay. 4 plus 3, 7. Right. 1, 7, 17, 20, 16, 7. 1, 7, 17, 20, 16, 7, 7. Right. Now our graphical procedure result is verified. So now where to indicate this arrow mark? If we do for cross check using the matrix method, in x of n, what is the starting position? If this is x of 0, this point is x of minus 1. In h of n, what is the starting position? Nothing is mentioned, so this is 0 position. So position 0, no, you have to concentrate on position. Position minus 1 plus position 0. The result is minus 1. So the starting should be your y of minus 1. Then obviously you have to indicate the arrow mark. Right? If no arrow mark indicate, both signals are started at x of 0, h of 0. Then your matrix convolution result also starting with y of 0. If arrow mark indicated in somewhere else, check what is the first position of x of n. Here it is x of minus 1 plus first position of h of n, 0, h of 0. So minus 1, this position plus this position, you have to add. So your y of n starting values, starting sample should be at this particular position. That is y of minus 1 position.
సార్
Tell me.
ఒకవేళ ఎక్స్ ఆఫ్ ఎన్ దగ్గర యారో 3 దగ్గర ఉందనుకోండి,
Arrow 3. So
యారో
3
3 దగ్గర
meaning
ఉంటే అప్పుడు
for
వాల్యూస్
your
మారుతాయి కదా.
when these
వాల్యూస్
values
మారినప్పుడు
magnitude. So your doubt is
అప్పుడు
I will
మ్యాట్రిక్స్
write down
మెథడ్
separate.
అవుతుంది కదా.
Matrix magnitude will not be changed. I'll write down 1, 4, 3, 2. You are asking the question, if suppose at 3 is given,
Yes,
x
sir.
of h of n equal to 1, 3, 2, 1. This magnitude will not change. Okay, you try, you can verify, but your result would be 1, 7, 17, 20, 16, 7, 2. So what is the starting sample position? X of 0, x of minus 1, x of minus 2. Minus 2 plus 0. So this should be minus 2, minus 1. Now your y of 0 at 17. You can check. You do it in the graphical method, you will get definitely this answer only.
ఓకే సార్.
Okay. If nothing is mentioned, by default, this is your starting point. No need to indicate your arrow. So position of the signal 1 plus position of the signal 2. Add together minus 2. So this starting should be minus 2 position. So then this would be minus 1 position. Then this should be a 0th position. 0th position, you have to indicate the arrow. Right. Okay. Thank you for your patience, and I'll solve one more problem, not in this method. Okay. So please go through this lecture once again and try to solve some other problems. Right. So this is type 1 in discrete time signal, type 1. Two finite samples, x of n also finite sample, h of n also finite sample. Suppose if finite samples are not given, find the response of LTI system. whose input is x of n equal to 2 power n u of n, and impulse response of Lte system equal to 1 by 3 power n u of n. Okay. Please be patient. I need to cover some problems because tomorrow holiday. Okay. Right. The question is, find the response. Find the response of an discrete time LTI system. Discrete time LTI system whose impulse response and input of the system follows, or compute discrete time convolution. Compute discrete time convolution, or compute convolution sum. Both are same. Convolution sum meaning by default you have to use the formula y of n equal to summation x of k h of n minus k, where k varies from minus infinite to infinite in general. Convolution integral meaning continuous time convolution. We will discuss in the next class the continuous time. Right. So the previous one is very simple. Actually, that is very simple. Steps are involving, but simple case. If this kind of signal given, how to solve it? X of n equal to 2 power n un, h of n equal to 1 by 3 power n un. The procedure is same. Plot x of k, plot shifted version of this h of k signal. That is h of minus k. H of minus k represent at n equal to 0. Right? This is fixed. Then minus 1 minus k, minus 2 minus k, and so on. Up to, is there a common overlapping between x of k, h of n minus k? Negative value of n. Okay. Then positive value of n. 1 minus k, h of 2 minus k, and so on. Up to a common sample between x of k, h of n minus k. We have to repeat the same procedure as like the previous one. But previous one is finite sample. Here it is infinite sample. Un meaning 0 to infinite. So to solve this kind of problem, we have to check the overlapping region and identify the summation limit. General formula minus infinite to infinite. But according to this problem, the summation limit will be changing. Okay. So how to solve this problem? First step, x of k. All n replaced by k to avoid the confusion in the problem. K versus x of k. 2 power n u of n. Okay. So u of n represent by default 0, 1, 2, 3 up to infinite. The magnitude are 1. X of k equal to 2 power n u of. So if you multiply 1 dot 2 power n, your sketch is equal to 2 power n from 0 to infinite. From minus 1 to minus infinite, no signal. I'll write down un. Un represent 0, 1, 2, 3, 4 up to infinite. The sample magnitude is 1. Okay, this is un. 2 power n meaning n equal to 0, 1. Okay, n equal to 1. So this will look like your increasing exponential. So I'll draw like this. Okay. N equal to 0, 2 power 0, 1. N equal to 1, 2 power 1, 2. N equal to 2, 4. N equal to 3, 8. Correct? 2, 4, 8, 16, and so on up to n. So if we multiply 2 power n with un, 1 dot x x. So the sketch for 2 power n u of n, this is the sketch. Okay. Negative value of n, 0. Because u of n valid from 0 to infinite. From -1, -2 up to minus infinite, 0. So do you understand how to plot 2 power n un signal? So this sketch for oh, 2 power n un. As per the formula, we need h of minus k only here. This is equal to at n equal to 0. So y of 0 equal to summation x of k h of 0 minus k. Okay. So what is h of k? 1 by 3 power n u of n. 0, 1, 2, 3, 4, 5, and so on. 1 by 3 power n un. So this signal also having u of n term, which represents 0 to infinite only. Thus 1 by 3 power n is valid. So anything power 0, 1. 1 by 3 power 1. So 1 by 3 is less than 1. So obviously your signal is decreasing exponential. This is k versus h of k. But as per the formula, at n equal to 0, we need x of k plotted already, h of minus k, h of minus k. So 0, -1, -2, -3, -4, and so on. So 1, 1 by 3 power 1, 1 by 3 square, 1 by 3 power 4, and so on. Decreasing exponential up to minus infinite. Correct? This is x of k. This is h of minus k. Now if you multiply these two signals at k equal to 0, at k equal to 0 values available. Right? Your y of 0 value is what? 1.11. Your y of 0 value 1. Correct? Next, can you plot h of n equal to -1 in the formula? So in the formula, y of -1 equal to summation x of k h of -1 minus k. How to plot -1 minus k? If you know minus k already, -1 minus k represent your h of minus k signal shifted left side by 1. -1, -2, -3, -4, -5, and so on. So your signal will start from here. 1. 1 by 3 power 1, 1 by 3 per square, and so on. This is at n equal to -1. Now multiply your x of k, h of -1 minus k. Is there any common sample between these two? Here signal starting from 0 up to infinite. Here signal available from minus infinite to -1. So if you multiply these two, your y of minus n value equal to 0. No overlap. Then n equal to -2, no overlap. N equal to -3, no overlap. Okay. So first what you have to do for this kind of infinite sample problem or general expression problem, you try to plot x of k first, h of minus k, then check n -1, -2, -3 up to the sample will get overlapped. So in this example, at n equal to 0 only one sample getting overlap. N equal to -1, no sample overlap. So n equal to -2, again further the signal will be shift left side. No overlap. So in this example, your y of n is 0 for n is less than 0. Okay. First you have to identify this by checking, by plotting different values of n. You have to identify when your y of n is 0. Okay. So y of n valid at n0, n1, minus k plus 1 or 1 minus k. How to plot? Y of 1 equal to x of k h of 1 minus k, correct? Or minus k plus 1. Or minus k plus 1. So how to plot h of minus k plus 1? If you know minus k signal, then plus 1 represent your h of minus k signal shifted right side by 1. So 0, 1. Minus k plus 1. This signal shifted right side by 1. This shortcut. On unit 1, actually, I suggested to you how to plot h of 1 minus k signal, h of minus k plus 1. K plus 1 first and then time reversal. This will be equal to this operation. Instead of doing k plus 1 first and then taking time reversal, that will be equal to time reversal and then shift the signal right side by 1. You can verify it. 0, -1, -2, -3, -4, and so on. Right? So now x of k, k0, k1. Two samples are overlapping, correct? K0, k1. Two zeros are overlapping. Minus k plus 2. 3 sample will get overlap. Minus k plus 3. 4 sample will go overlap. Because this x of k signal available from 0 to infinite. So it is not possible to shift your h of n minus k signal for n 1, 2, 3, 4 up to infinite. It's very difficult. So we need to follow some formula. So what is that? How to identify the summation limit? Okay. Now you have to draw the generalized diagram h of n minus k. H of n minus k diagram for n is greater than or equal to 0. Because we identified in this particular problem n0 overlap available, common sample available between x of k, h of n minus k. n1, n2, 3, 4 and so on. So I'll put for n is greater than or equal to 0, I'm going to draw a generalized diagram for h of n minus k. Okay. So how to draw this generalized diagram? Simple technique. Where is h of minus k? This is h of minus k. What is the rightmost sample value? K value 0. So 0 plus n. Okay. 0 plus n. Just put n value. Okay. Minus k. Leftmost k value minus infinite. Okay. Minus infinite. Here also minus infinite. This n may be anything. Okay. This n may be 0. 0 meaning this will come here. If n equal to 1, meaning this will come at this position. N equal to, I am drawing generalized diagram. N is greater than 0. This n may be anything, either 0, 1, 2, 3, 4, up to infinite. Up to minus infinite. Here it is up to minus infinite. So this is generalized diagram for n minus k. So do you understand how to draw n minus? First we have to check the different values of n. N0 overlapping possible. That is, your y of n is non-zero. N minus 1, if you multiply x of k, h of minus 1 minus k, your result is 0. If you substitute n equal to minus 2, again the signal shifted left side, then your y of n is 0. So in this problem, we identified y of n is 0 for n less than 0. What do you mean by n less than 0? N minus 1, n minus 2, n minus 3, up to minus infinite. And n0, 1 sample overlap. N equal to 1, 2 sample overlap. N equal to 3, 3 sample, and so on. So it's an infinite signal. So we have to draw the generalized diagram for h of n minus k. How to draw generalized diagram? H of minus k, just add n with this. Okay. So here 0, whatever the k value available here, 0 plus n, minus infinite plus n minus n. So this is your n minus k diagram. So shall we combine x of k also with this, so that you can identify the summation limit easily? X of k equal to 2 power n u of n. That is 0, 1, 2, 3, 4, and so on. 1, 2, 4, 8, and so on. Okay. Now already we identified y of n equal to 0 for n less than 0. Okay. This n may be anything I told. It may be 0, or it may be 1, or it may be 2, 3, and so on up to infinite. Now your limit y of n equal to summation x of k h of n minus k. So k equal to 0. K equal to 0. In this portion here, entirely 0. So 0 dot anything 0. So starting overlap is k equal to 0. Ending overlap, rightmost point, n. This n value anything, n is greater than 0. So k equal to 0 to n. K equal to 0 to n. Now you have to solve this problem. Substitute your x of k value. K equal to 0 to n. X of n equal to 2 power n. 2 power n u of n. So 2 power k. U of n meaning magnitude 1 only. H of n minus k. 1 by 3 n minus k. Dot u of n magnitude 1. Now you have to simplify this expression. K equal to 0 to n, 2 power k, 1 by 3 power n minus k. Okay. K is the variable here, 0 to n, 2 power k, 1 by 3 power n. 1 by 3 power n is a constant. Okay. Then 1 by 3 power minus k. So that you can write it as 3 power k. So 1 by 3 power n constant. K equal to 0 to n, 2 power k, 3 power k. 2 power k, 3 power k. You can write it as this. So 1 by 3 power n, 0 to n, a power n. Okay. K value. K is the variable here. 0 to n a power n. What is the formula? Summation n equal to 0 to n a power n. 1 minus a power n plus 1 divided by 1 minus a. Right? So 1 minus 6 power n plus 1. 1 minus 6. Okay. So 1 minus 6 is there. So I can multiply both numerator denominator by minus value. So I'll get 6 power n plus 1 minus 1 divided by 6 minus 1, 5. So this is your y of n value for n is greater than 0. This is very important. Okay, no need to substitute your n 1, 2, 3 and so on. This expression is sufficient for you. Okay. The most difficult part in signal sense system is convolution problems only. Okay. Unit 1, 3, 4, 5, all the problems are somewhat easy. Convolution also simple problem, simple only, but you have to understand the concept. Now you can ask your doubts. So we solved only 2 problems. Both are simple. First problem, finite sample simple. Second problem also infinite sample. This is a kind of simple problem only because more problems are available. We will discuss one by one. Any doubt in this particular step? Are you feeling difficult or easy? Procedure is same. Okay. Please, I need your feedback. Within another 5 to 10 minutes, I'll leave you. I'll summarize the step. Second problem. One signal is fixed, that is x of k fixed. Another signal, time reversed signal we have to plot, that is h of minus k. Then you have to plot different h of n minus k diagram. Okay. Plot h of n minus k diagram for different values of n. n0, n1, n2 and so on, as well as n minus 1, n minus 2 and so on. Okay. So from this problem, we came to the conclusion that whenever n minus 1, minus 2 and so on, there is no overlap. So we have written like this. For positive value of n, the samples are getting overlapped. But this is infinite sequence. We cannot calculate for each and every shifting y of n value. So draw the generalized diagram for n minus k. N minus k for n greater than 0. Because n less than 0, no overlap. So how to draw n minus k? H of minus k diagram, rightmost k value 0, so 0 plus n. Here minus infinite plus n minus infinite. That's it. Now sketch h of n minus k, x of k in the same axis, k axis. Then easily you can identify. See, from 0 onward signal started here. Here nothing is there. So starting sample would be 0. Ending is n. This n may be 0 or 1, 2, 3 or whatever it may be. Sorry, k value 0 or 1, 2, 3. That's why I written the general expression. N is greater than or equal to 0. Don't substitute infinite. Then you can your answer will be wrong. right? N is greater than 0. N 0 or 1, 2, 3 and so on. So summation limit, once you identify the summation limit, then x of k h of n minus k. What is x of k? 2 power k into uk. So 2 power k uk. U of k value 1 for positive value of k. H of n minus k. H of k equal to 1 by 3 power k uk. H of n minus k 1 by 3 power n minus k u of n minus k. U of n minus k value 1. Okay. So this is your x of k and this is your h of n minus k.